homework and quiz and test grades. All right, here we go. All the algebra's done. We're moving back to proofs. Not right away, but we will here in a minute. Talking about congruent polygons. When are two triangles, two quadrilaterals congruent to each other? So right here in the givens, take a quick peek. That's where I want to start. What am I telling you about these two figures here? All right, based on that given, what am I telling you about these two figures here? Let's get it started. Sophie, what am I telling you? All right, yeah, they're congruent. So what the heck does that mean, that they're congruent? Because congruent to us means they're the same length, same angle measure. So what the heck does it mean when two figures are congruent? Here is what it means. Everyone, take quadrilateral ABCD for me. And I want you to put it right on top so it matches up. All right, so you're going to have to flip it and slide it. Put ABCD right on top of WXYZ for me. Put them right on top for me. First thing I'm going to ask somebody, name a pair of sides that would match up. Name a pair of sides that would match up if you took ABCD and put it directly on top of ZWXY, so the sides and angles all match. So what two sides would match up? Just give me two sides that you think would match up. Connor?
D and C and Y and X.
Okay, hold on. You said D and C. So you're talking side DC? I want two sides that match up. Two sides.
Never mind. I mean, XA and ZC.
Okay, those are on two different. Okay, ready? Give me a side. Here we go. Give me a side from this quadrilateral.
DA.
Okay, DA. What would DA match up with over here? That's what I'm asking. DA would match up with what if I put this one right on top of this one?
XW.
DA and
XW.
You sure about that? Flip it and slide it.
Oh, YZ.
YZ. Are we good there now? We good?
Yeah.
Everyone knows what I'm asking? Maybe I wasn't too clear there. YZ. Now, they match up, correct? And Sophie, going back to you, what did you know about these two quadrilaterals? Which means these parts that match up, these sides, are also congruent to each other. That's what that means. If those two are congruent, so are all the angles and sides that match up. That's not the only two sides that match up. Let's keep it going. Name another two pair of sides that would match up with each other. CD and XY. I agree with that. So that means CD and XY, since they match up and the quadrilaterals are congruent, so are those sides. All right, we're still not done. We got more sides here that match up. Give me another pair of sides. Ooh, there we go. John?
Oh, wait, WZ
Yep.
BA.
All right, I'm good with that one. BA, congruent to WZ. And then there is a fourth and final pair we have not talked about yet. And that pair, Scotty?
AB and W. Oh, wait, no.
Yep, you're fine. Got it.
CB
Mm-hmm.
XW.
Yep, CB congruent to XW. Good. So is everyone good there? All right, the sides match up, so do the angles. Right? There's four pairs of angles that match up. Give me a pair of angles that would match up if I put these two right on top of each other. Give me a pair of angles that would match up. Lucy, one pair?
C and X.
C and X. I like it. Hey, ready? C and X match up. Since the quadrilaterals are congruent, so are those two angles that match up. Give me another pair that match up, please. Another pair. There we go. Theodore?
Angle B and angle W.
Good. So that means B and W are congruent to each other if the quadrilaterals are congruent. And one more pair. Give me one more pair that match up there. Aylin?
Y and D.
Y and D. Yep. And this is just process of elimination here, but the final pair, angle A, matches up with angle Z. So if the polygons are congruent, so are their matching parts. Now, I'm tired of saying matching parts. Right? They actually have a name to them. All right, these matching sides and matching angles. They are called, and it's probably a term we've been familiar with. They're called corresponding parts. Where did we hear that word corresponding again? Angles, right? With parallel lines, because what? We put that 4-pack down and we said which angles match up to each other. All right, so instead of saying the sides and angles that match up going forward, let's say corresponding parts. I also have a secret before I let you guys go to the next one. I have a secret. As I started calling on all these people and they started telling me those sides and angles, I never once looked at the diagram to see if they were correct. I never once looked at the diagram. And it's not because I've memorized this, because I've been doing this for 800 years. All right, how did I know that they were correct, that they matched up the correct sides and angles? You want to know my secret? I didn't need the diagram. You know what I looked at? I looked at this right here. That's called a congruent statement. All right, so just so everyone know, that's called a congruent statement. How did I use that to figure out if they were right or wrong? Who gave me this first one here? Connor, you gave me this one, right?
Mm-hmm.
DA. Everyone look where D and A are in the congruent statement. Isn't it in the first and the fourth spot? Look what's in the first and the fourth spot in the other quadrilateral. Z and Y. Okay. These congruent statements are written in a particular order so you can match up the corresponding sides and angles. Does everyone see what I'm talking? Because you're going to have to write your own eventually. All right. So, for instance, who gave me C? Lucy, you gave me C and X, right? Mm-hmm. I didn't have to look at the diagram because I saw C was in the third spot and so was X. So they had to match up. Everyone all good? That's how the congruent statements are always written, with the corresponding sides and angles written in order for you. Good? All right, here we go. I told you they were coming back. And, whoa, maybe not coming back right away, huh?
Wait,
All right, here we go. Again, very low energy at all.
Slide left.
Swirl. Curtain.
There's no such thing as swirl.
Wait, if we get it, does that mean we just like stop learning?
No, it just means you have no homework this weekend.
Up. Is cube on? Up. Like the.
Yeah, like
It's
slide
supposed to be
out.
star.
Oh, swing.
Isn't there slide like up?
Swing.
Genie.
Yeah, slide up, slide down.
Use its proper name.
Up, slide up.
There's no such thing as slide up.
Swipe up.
There's no swipe up.
Down.
Pinwheels.
Clock. That is not close to A. We had so many more.
Probably about 3 more. I could
Star.
definitely think of one of them.
Oh,
That's
fade, right? Fade or left.
Oh, slide left, slide right.
It's up and down, but we don't know the names.
It's like this
Definitely missing. I can think of one.
spin.
Not the one I was thinking about, but that is one.
Reverse.
Anything else before we vote?
A float or something? What's the
I don't know. A
vertical
float.
one?
I don't know a vertical.
Fly.
Probably 2.
Genie.
Wait.
Oh
Yes.
Anything else?
Is there like a circle?
There's clock. I don't know if that comes. Okay, we ready to vote so I can move on? All right. Top vote getter, remember. Vote for who you want. All right. Stars. Anybody think it's going to be star next? Pinwheels. Slide left. Right. Promethean person again. Double. Book. Curtains. Remember, you can only vote once. Swing. Shatters. Cube. Genie. Clock. Flip. Fade. Spin. The ones you forgot were page curl. Page curl, where it curls from the corner. No, book is, and then there's drop. There was a drop. All right, we ready?
That's a vertical.
Curtains it is. If it's next one's curtains. We ready? No homework this weekend if it's curtains.
It's not gonna be good.
Silence.
It's gonna be the page flip.
No, it's gonna be
It's
pinwheels.
gonna be like, yeah, it's gonna be pinwheel.
Everybody.
We ready? Curtains is up. Ooh, the page curl, the one that was not nominated. Page curl. Page curl. Okay. All right, here we go. Ready. Next up. Here we go. Back to proofs now. Decide whether these triangles are congruent, and we're going to do this in a proof form. I need to know if the triangles are congruent. So how am I going to do that? Well, what did we just say? If these quadrilaterals were congruent, so are all their corresponding parts, right? So that's what I need you to do in this proof here for me. Prove all the corresponding sides and angles are all congruent in those two triangles. So all three pairs of angles and all three pairs of sides are congruent. That's what I need your help with. If you can do that, then we can say the triangles are congruent. So I see some of you guys going. Go ahead and mark your diagram up. And then we'll see if these two triangles are indeed congruent or not. Let's see, I got B and D are right angles. We got a lot of hash marks going on, I hope. We got AB congruent to ED, doubles on BC and CD. And we also have, look at all this givens. AC congruent to CE, perfect. And again, they won't be congruent unless all of the corresponding parts. Well, how many sides do we have congruent already?
3.
All of them. All of them. We're good. What we don't have is what? All three pairs of angles. All right, so the three pairs of sides are done for us. They're given. You're welcome. Now we got to work on, are all three pairs of angles indeed congruent? Well, do we already know one pair is? What's that pair? B and D, the right angles. Have we said they're congruent, though? You're saying that in your mind, but is it on our paper yet? Nope. So we got to say B congruent to D. And this is nothing new. I know it's been since Unit 2, but this is nothing new. Why are B and D congruent? All right angles congruent. Done. One pair of angles done. Is it possible by looking at the diagram to get me another pair of angles? And this is where I know some of you are like, no, but some of you, this is where we got to be. We got to see them now. We got to see them. Kira, where are they?
Angle, like there's the two C angles that meet in the middle. Those are vertical angles.
Well, you can name them.
Angle BCA and angle ECB.
Good. Hey, this one. This is the one. The two we got to see this. We gotta. At this point, we have to, because what type of angles are they, Kira?
Vertical.
They're vertical angles. And I'm glad Kira made that little mistake at the beginning. Don't tell me angle C equals angle C. That's garbage. All right, we name it with 3 letters, right? 3 letters. Angle BCA is congruent to angle ECD. And what was our reason? Vertical angles are congruent. Guys, I'm being upfront with you. We got to notice the vertical angles at this point in the year by now. Because they'll never be marked congruent for you. That's your job. Okay, we're moving, aren't we? All I need is what? One more pair of angles, and that's what? It's got to be angle A and E, right? Try to get angle A and E, and I could stand here in silence for the rest of the class, and nobody's going to get why they're congruent. By the way, I know some of you may say they're alternate interior, which they are, but what type of lines do they need to be congruent? Do I have parallel lines?
No.
Okay, so that's out. That's out. Okay, can't tell me alternate interior angles because I don't have parallel lines. So here's what I got to teach you today. What do all the degree measures in a triangle add up to?
180.
Right? This one adds up to 180, and so does that one. Don't I have 2 pairs of angles already congruent? So shouldn't the third pair automatically? Watch. Please don't write this down. Just stay with me. I'll give you some easy numbers here. 70, 80, 70, 80. These 2 triangles have 2 pairs of congruent angles, correct? All right, what is the remaining measure up here if that's 150? 30, right? And what is it up here?
30.
Oh, so if you have 2 pairs of congruent angles, the third pair must be equal as well. Agreed? Okay, so I want to write that down in your theorem box first. All right, this new theorem we're going to use. And you guys have one right down below. So in 2 triangles, all right, in 2 triangles, if 2 pairs of angles are congruent, so are the third pair. And after I write this down every year, I always get a couple kids, and even in the honors level, believe it or not, they give me a little whine time. You expect me to write all of that and memorize that and write it in the reasons column? Are you kidding me? Oh, my wrist is going to hurt. And then you know what I got to do? I got to go over the phone. I pick up the phone. You know what number I call? Wine 11. Yep, wine 11, because you know who needs to come? The wambulance. Yep, the wambulance. I got a million of them. So I give in. I cave here. I cave. No, I don't need you to write the whole thing. You can just write it by its actual name. This is called the third angles theorem. All right, what you just wrote there is called the third angles theorem. And that is what you can write here. Y angle A is congruent to angle, was it E? Yep, angle E, third angles theorem. Just so we're all clear, there is no such thing as the third side theorem. That if two sides are equal, the third pair must be. That is not true. Only with the angles. Go ahead, Sophie. Sure. Whoa, we're not done. Did we prove all three pairs of sides congruent? Yep. How about all three pairs of angles?
Yeah.
So now what do we know about the triangles? They're congruent. Now I need to write that correctly. I need to write it correctly. What am I talking about? Give me somebody up here. Twos. Just win. One job. Be here. Gage, name one of the triangles any way you want. Triangle.
Triangle BAC.
BAC, you got it. So I'm going to start this with triangle BAC. Perfect. Now, the way congruent to, the way you name the second triangle matters. Because what did we just talk about with the quadrilaterals? When you write a congruent statement like this, the sides and the angles need to match up. So you cannot call the next triangle anything you want. It has to go in a particular order so the angles and the sides correspond to each other. So I'll give you a minute to think about it before I call on somebody for the correct one. So if I go BAC, I'm going to have to go what for the second triangle here? BAC and Abby?
DEC.
DEC looks good to me. Perfect. And our reason for this, and this is only going to be our reason for today and today only. We'll have a different one on Monday and next week. Definition of congruent polygons, which says, hey, if you have all the corresponding parts, the polygons have to be congruent. Okay, all good. One doesn't make you great. We got another one on tap, but any questions here? You have to get all 6 corresponding parts congruent somehow. That was fun. Let's do it again. Mark your diagram up. Oh, what's that symbol again in between GN and CD?
Perpendicular.
Perpendicular, good. Yep, hopefully, I'm praying, hopefully, we can put those right angle symbols on your diagram. And the proof statement says, all right, prove the triangle's congruent. Well, I need all corresponding sides. Do I have all corresponding sides? No, I only have how many pairs? 2. All right, well, let's start there. Why don't we start there? Trying to get the third pair. And again, there's no such thing as third side theorem, so that's out. But we can still do it. What sides are you trying to get congruent then? I have CG and GD. I have CN and ND. So what are that third pair from each triangle that I need to get congruent here? What is that third pair here? Let's talk here. Aylin, what's the side I don't have from triangle CNG? And what's the side I don't have from NGD?
Oh, GM.
I don't have GN from one triangle, and I don't have GN from the other. What do you know about the two? GN and GN, those sides? They're congruent to each other, aren't they? Yes. GN congruent to GN. There it is, reflexive. Coming back for us. So now I do have all three pairs of sides, don't I? You can have a reflexive side. All right, let's turn our attention to the angles. How many pairs of angles was I given congruent? Just the one, C and D. So we need to find the other two. And how about you use your markings? What'd you mark on your diagram, Gage? The right angles. Everyone, yeah? Quick though, can I say they're congruent in step 3?
No.
Anybody remember? No, I cannot. Why not? I need to tell you
You have to define
Where they are.
where they are. Why didn't I do that in the last proof? Because it was already given. I need to tell you where they are. All right, so somebody name where the right angles are here. Aylin, again, name where the right angles are. Angle G and C and angle G and D are right angles. How do we know they're right angles? True. Where are we going? Kevin, how do I know they're right angles? Okay, you just put a word there that never showed up in our proof. What made you put the right angle symbols there? Why did you put right angle symbols on your diagram? Why? You didn't do it because it looked like it.
Okay, not bisector. It wasn't definition of oh no. Perpendicular lines form right angles.
Good save. Good. Get used to this. Get used to this. You tell me they're right angles. In the very next step, you're going to tell me what about them now. They're right angles, and then very next step, Bennett. Tell me they're congruent. It's going to be a 2-step. Come on. Go ahead. Keep going. You don't have to wait for me. Technology pet peeve. Work. And they only gave me reflexive back. Just give me a second. If you guys want to try to finish it, feel free where that other pair of angles is going to come from. How do I get that last pair of angles congruent? If you want to talk about it in your group, go ahead. We got the right angles and C and D. What about the other pair? How are they going to get congruent?
It's like the one.
Okay, I'm caught up now. The third pair of angles. Angle CGN congruent to angle DGN. Why? Again, please do not add in words that never popped up here, right? Don't add in bisector, midpoint. They're not here. They don't exist. So why would have the last pair of angles need to be congruent? All right. There we go. Tess? Third angles theorem. That's what's coming in now. Third angles theorem. I am not going to make a big deal of matching up the corresponding sides when you write this statement because it's right up there in the proof. Right. Just copy it down. Triangle CNG congruent to triangle DNG. Definition of congruent polygons. All right, feel comfortable there? If two triangles are going to be congruent, all their corresponding angles and sides must be congruent as well. Good? So we're done with proofs for today anyway. What class are we in? Good job. So we need to do a problem that I don't do in my AB level. All right, just in my honors level here, which is find X and Y here. I think Tess asked it, a question on the homework. And I, at all costs, avoided having an X and a Y in the same equation. right? I wanted all the same variable. We do not get that luxury in this problem. So I wanted to go over, when you do one on homework tonight, how do I get around that? Everyone see the congruent marks on your paper? Did I make them pretty clear, I think? Okay, so those angles are congruent. This has nothing to do with, these triangles are not congruent, right? Because I don't know anything about the sides, but at least the angles are, so I can match up the congruent angles. So can somebody match up a pair of angles that you know are congruent so I can set them equal to each other, right? Set them equal if they're congruent. Anybody have a pair of angles that are congruent? Start us off, Sophie. 148, and then this one right here?
Yeah.
Okay, they are congruent, but I don't know what this one is. So I can't set them equal, right? Okay, so you're going to do 148 plus 1 equals 148. Is that what you're going to do? I'm just at, I get one. Oh, yeah, I got it. I'll put 148 there.
And then 3x plus y.
All right, you got me there now. Okay, keep going. You're going to steal my fire.
Okay, go back to the one with the double line. Like the other one.
So you're saying 3x plus y is equal to whatever this angle is.
Yeah.
Can we find that angle? I hope so. What was our discussion yesterday? All three of these add up to what? 180. All right, let's find that missing angle then. So I could set it equal to 3x plus y. And that missing angle is 14 degrees. Yep. All right, so those match up. Is there another pair of angles up here that match up that I can write down? Violet?
18 is 5x minus y.
5x minus y is equal to 18. Good. All right, so now I have what's called a system of equations, and this one's not bad, is it? What do you notice right away? The y's, right? See ya! They're gone. So how many x's are left?
8.
I'm left with 8 x's, and how about the 14 and the 18 when I combine them? 32, yep. So x equals 4, but it also said to find y, so what's our go-to now?
5x minus y, 18.
I could pick one of the two equations I started with, right, and plug in 4 for x. So go ahead. Yep, go back to one of the two equations you came up with. So no matter what equation you plugged it into, y would be equal to 2. And I'll be honest with you, I totally thought Sophie was going to blow my cover here. This is the way I wanted you to do it because that's the way it's going to have to be done this weekend. But I totally thought when she said put 148 here, that my cover was going to be blown and somebody else was going to tell me to do it a different way. Just using that triangle. What do I mean? What do all those angles add up to?
180.
180. And what's going to happen to the y's when you do that? They're going to cancel, so you'll just have 8x plus 148 equals 180, and you could have done it that way too. Okay, but I know on the homework this weekend, you're going to have to set up two equations and solve them. Zach?
You won't be able to do that if the y's don't cross out.
Correct, yeah, then you're in trouble.
Yeah.
Yeah, you'll just have another equation with an x and a y to work with. Yep. And final thing today before I let you go, I want to make sure you can write your own triangle congruent statement. Before you do that, though, I got a big problem with this. They're saying, I don't agree that these are congruent. I don't agree that these are congruent because I was taught today that all corresponding sides must be congruent, which I have, and all corresponding angles have to be congruent, and I only see 2 of them marked for me. H and R are not marked, so I disagree that they are not congruent because I don't have all 3 pairs of congruent angles. But anybody want to tell me why I could be on the safe side here, Sophie? Third angle theorem, yes. H and R have to be congruent. I don't need to mark them. They have to be congruent by the third angle theorem, correct? All right, so let's write a congruent statement. Somebody name that first triangle any way you want. Any way you want there. Violet, how do you want to name that first one? Triangle? Sure, you got it. DFH. So if we're going triangle DFH, that second one has to be in a particular order now. Remember, match up the sides and angles, and I do look for this on your quizzes, that you match up everything correctly. So if I go DFH, we got to go triangle. What do we got over here now? Oh, Violet again. Finish your job. ZPR. Let me take a quick peek. D and Z match up. Yep. F and P. Looks pretty good to me. Now, is this the only correct answer? No. I call on somebody else other than Violet. They may give me another name for the first one, which affects the second one. All right. So this is not the only way to write a statement. Questions, comments? All right. Let's